Alright, so here we've got a bit of an example of sort of ways you could handle concentration calculations. Okay, so here we're told that 6.4 grams of potassium nitrate is dissolved in 300 milliliters of water. Okay, and we're asked to find the molar concentration of nitrate ions in this 300 ml of solution. Okay, so the way we're going to do about doing this, okay, we know that we're going to need the molar mass somewhere in this calculation. Okay, so a good first step is going to be to find the molar mass of potassium nitrate. Okay, so that's what we need to first do, is find the molar mass of potassium nitrate so that we can find the number of mole of potassium nitrate. Okay, so the molar mass is going to be equal to the sum of the molar masses of all of the atoms in the compound. Okay, so we've got one potassium atom, one nitrogen atom, and 3 oxygen atoms. Okay, so the molar mass of potassium is 39.1 grams. Molar mass of nitrogen, 14.0. So remember that these molar masses are all basically just the atomic masses on your periodic table. Okay, they're the exact same number. Okay, and we've got 3 oxygens, and they all have molar masses of 16.0 grams. Okay, so that means our molar mass, if we add these together, is 101.1 grams per mole. Okay, the units are essential, just so that you can keep track of sort of what you're doing and what all the units are and what they all mean. Okay, it's a very, very, very good way to sort of help understand what's happening. Okay, so that's the first step. We found the molar mass. Okay, and then we know that we've got two methods by which we can find the molar concentration. Okay, here we're going to use sort of, I guess, the more straightforward one. Okay, we're going to find first the number of mole of potassium nitrate. Okay, remember, it's always good to write the thing that you're working out in brackets. Okay, write the substance that you're talking about. Okay, so I should have done that up here. This should really be, just to avoid confusion, the best way to deal with this is to write just so we keep track of quite obviously and quite easily what exactly is happening in our calculations. Okay, so we know the mole of nitrate. Okay, so this looks a little bit tricky. Okay, so we want to find the mole of nitrate. Okay, and so what the information that we need to work this out. Okay, we need to know that if we have 1 mole of potassium nitrate, then that is equal to 1 mole of potassium plus 1 mole of nitrate. Okay, because 1 mole of potassium nitrate means we've got 1 mole of potassium ions and 1 mole of nitrate ions, and they're bonded together. Okay, so 1 mole of nitrate. Okay, so that means the mole of nitrate is going to be equal to the mole of potassium nitrate. Okay, we know how to work that out. We know that the mole of potassium nitrate is going to equal the mass of potassium nitrate over the molar mass of potassium nitrate. So that equals, we've got 6.4 grams divided by, we've got what we worked out earlier, 101.1 grams per mole. Okay, we've got 6.4 grams up here. Okay, so that gives us 0. So we put that in our calculator, we get 0.063 mole of potassium nitrate, and therefore, based on this ratio here, 0.063 mole of nitrate. Okay, so that's our second step. Okay, and then we've got one more step in order to get the answer. Okay, so we want to know the molar concentration. We know that concentration of nitrate. This is our basic formula, the pretty self-explanatory one, easy to work out on the run how this formula might look. Okay, so we want molar concentration, we want mole per liter, so we're just going to divide the number of mole by the number of liters. Okay, So the mole of nitrate. Okay, and we're going to put, although it might sound a bit weird, we're going to talk about the volume of nitrate, okay? Only because we're not actually saying the volume of nitrate ions. We're going to say the volume of the nitrate solution. That's what we mean when we write V brackets NO3 minus, okay? We're talking about the volume of nitrate solution, okay? Because in a lot of situations we'll be dealing with more than one solution, okay, containing different compounds. And so we want to make sure we're keeping, we're using the right volumes in each of our calculations. Okay, so we want mole of nitrate over volume of nitrate. So we've got 0.063 over, we've got 300 mil, which is equal to 0.300 liters. Okay, and that gives us an answer of, so let's write mole there, 0.21 mole per liter. Okay, so that's our final answer. So we've got 3 steps here. We've worked out the molar mass of potassium nitrate. Okay, and what that's allowed us to do is that's allowed us, here, it's allowed us to work out the mole of potassium nitrate and consequently the mole of nitrate using this ratio. Okay, because we know that 1 mole of potassium nitrate obviously has 1 mole of potassium and 1 mole of nitrate. Okay, then once we've got that mole of nitrate, we know that the concentration of nitrate is going to be that number of mole divided by the volume of the solution. So here we've divided the number of mole by 0.3 liters and we get out 0.21 mole per liter.